Okay, sorry, my video totally cut off and I'm gonna start fresh. All right, so here's where we left off, hopefully. So our factors were negative 20 and 2, so that means our middle term was created from a negative 20x plus 2x. And then I'm just gonna bring down my first and last term. And so there's our original 4 term polynomial, and then we're going to split it down the middle, and then you're basically just going to do GCF of both sides. So the GCF of the left side is 5x, and if I divide that out of each term, I'm going to be left with x minus 4, and then on the other side, my GCF is positive 2, and if I divide that out of each term, I get x minus 4. Now I do GCF one more time. These two terms have an x minus 4 in common, so I'm going to take that out, and then the 5x plus 2 is what's left. We're not done, however, because we still have to solve, so we're going to set these factors equal to 0, which gives me x equals 4 and x equals negative 2/5. Now, what you need to make sure of is if you plug it back in, does it work, right? And so the 4 definitely works, right? That gives me 16 times the 5, and then you're subtracting 72, and that does give you 8. So x equals 4 is one of your answers. But guys, the negative 2/5 also works because you're squaring it, which makes it positive, and this number is bigger than the second term. So anyway, plug it in and your calculator and double make sure that it works when you plug it in to give you 8 for the other tangent, okay? All right, number 17. I'm going to label everything they give me. Arc DC is 8x minus 3. Arc BE is 5x minus 12. And angle A is 4x minus 7. Well, this is just a exterior angles problem. And we did a bunch of these on the first page, right? That the exterior angle is equal to half the difference of his two intercepted arcs. Now, we talked about this one in class. Sorry, I'm trying to find room. So exterior angle, 4x minus 7, is half the difference. Now, this one you got to be careful because we're subtracting 8x minus 3 and 5x minus 12, which are both binomials. And you cannot forget that when you subtract a binomial, that minus sign has to distribute to each term in that second binomial. Okay, now I'm also going to go ahead and get rid of my 1/2 by multiplying this side by 2, or both sides by 2, but that's just going to get rid of the 1/2. If you don't like solving it the way I'm doing it, then that's totally fine. We can all do it in different steps. We're going to get the same answer. So on the left, if I double everything on the left, I'm going to get 8x minus 14. And then on the right, I'm doing 8x minus 5x, which is 3x. And then I'm doing negative 3 minus negative 12, which is actually negative 3 plus 12. So I get plus 9 here, right? And then when I do my math, I'm going to get 5x equals 23. And when I divide by 5, I get 23/5, which you're more than welcome to leave it like that. Or you can write it as 4.6, since it's a nice, pretty finite decimal. And if I were you on a test, if I got an answer like this after doing this problem, I would plug it back into my picture, right? And I would make sure that my outside angle was, in fact, half the difference of his two intercepted arcs after I plugged that x value back in. Okay. All right, moving along. Here we go, number 18. So it says arc BC is 66, okay. And then AD is 94. All right, so let's see here. All right, so there's a lot going on here. How your brain sees things may not be the same way of what I see. So it just kind of depends on how you want to do this. The first thing I notice is angle 1 is an inscribed angle. Sorry. that is intercepting that 66-degree angle. So that's the first thing that jumps out to me, which means angle 1 is going to be 33 degrees, right? Half of his intercepted arc because his vertex is on the circle. And then I happen to notice that angle 2 is also an intercepted arc to the 94, right? Which means he is 47 degrees. Then, of course, I can't help but notice that this is a triangle, right? Which means all of his interior angles must add up to 180 degrees, right? Which means this is going to give me exactly 100 degrees because angles 1 and 2 add up to 80 degrees. Which, of course, if that's 100 degrees, then I know angle 5 is 100 degrees because they're vertical angles. Okay. And then I happen to notice that angle 3 and 4 are also inscribed angles of the same 66 and 94. So angle 3 is inscribing the 66-degree angle, which means he's also 33 degrees. Sorry, I got a lot of colors going on here. And angle 4 is also an inscribed angle intercepting the 94-degree angle, which means he is also 47 degrees. Now, there are other ways you totally could have done that problem. I know some people might have noticed that given these two arcs, they could have used the sum or the average, and they could have solved for x by doing half the sum of 66 plus 94, and they would have gotten 80, which would have given them the 100. I mean, there's a lot of different ways you could have gone about this problem, right? I'm just showing you what I happen to notice first, because my brain always looks for inscribed angles before anything else. All right, here we go super quickly. My iPad is running out of charge. So AC is 140 and AFC, the angle, is 84. Okay. And they want us to find the measure of angle ABC, which is this one. All right, I actually really like this question because if I want to solve for angle X, which is an outside circle, I need his two intercepted arcs, which would be AC and DE. Well, I have AC, but I don't have DE, right? So that means I've got to go find another way to find DE. Well, it wasn't just coincidence why they gave you the measure of angle AFC. Notice that is an interior angle. So the 84-degree angle, is equal to half the sum of his two intercepted arcs. So I don't know what the measure of arc DE is, but I know if I add them with 140 and take half of that, it's going to give me that 84 in the middle. Right? So I'm going to solve this equation. I'm going to double the 84. So that's going to give me 168 equals 140 plus the measure of DE. And then, of course, I'm going to subtract that, and that's going to give me 28. Now, that's just, I'm not done, right? That's just the measure of arc DE. So this is 28 degrees. Now I can solve for X because X is the outside angle, and outside angles are half the difference of their intercepted arcs, which in this case is going to be the 140 minus 28. What's that going to give us? 1, hold on, sorry. Anyway, and we're going to take half of that, and we should be getting 112, so half of that is 56. Okay, so a little two-stepper there. All right, number 20. I'm going to label everything. AB is X, BC is 13, AE is 5, and ED is 1. That seems strange, but we're going to run with it. All right, so let's see. Now we're talking about segments. So this is our formula where, especially because we have secants here, remember this is outside times whole thing equals outside times whole thing, right? And that's going to be our algebra equation, right? So I'm going to do the top secant first. So outside is x, whole secant would be x plus 13. So that product is equal to the outside piece of the other one. And then the whole thing, of course, would just be 5 plus 1, which is 6. And there we go. That's our math problem. Well, you can see this is definitely going to be a quadratic because when I multiply this out, I'm going to get x squared plus 13x equals 30. Then I'm going to subtract the 30 because I need it set equal to 0 to solve. Now, this is a pretty easy, I'm going to go up here. This is a pretty easy quadratic because it has a 1 in the front. So I know I can just hop directly to the factors. The factors of negative 30. Here, let me make a little number puzzle or a little X. Or you can make your T-chart or just do it in your head. You don't have to write this down. So I want the two numbers that multiply to give me 30, but add to give me 13. And that is going to be 15 and negative 2. They're going to be our winners for that. Which means our factors are x plus 15 and x minus 2. And of course, that still equals 0. So we're going to set those factors equal to 0. And we're going to get x equals negative 15, but clearly it cannot equal negative 15 because x is actually the length of AB, and you can't have negative lengths. So that answer is a no-go, which means x equals 2 is going to be our winner. All right, next up, let me change colors because I wrote so much there. Here we go. So AE is 5, CE is 4, BE is x, and 12 minus x. Okay, now these are also segments, but these are segments that are trapped completely within the circle. So remember that formula is the product of each piece of the chord have to be equal. So we're going to do x times 12 minus x equals 5 times 4, right? So this piece times this piece has to equal this piece times this piece. Again, these are all formulas that you're going to want to put on your 3x5 note card. All right, so we're going to distribute. So we're going to get 12x minus x squared equals 20. Now, I don't know about you, but I never want to try to factor with a negative x squared. So I'm actually going to move these guys all over here to join the 20. Right, so I'm going to put my 0 on the left in this case. I'm going to add the x squared over, subtract the 12x, and then keep my positive 20 over there. Coolio. So now I'm just looking for the two factors that multiply to give me 20, but add to give me negative 12, and that is going to be negative 2 and negative 10. So that when I set, whoopsies, when I set these equal to each other, I'm going to get x equals 2 and x equals 10. Now, you could technically, does either answer work when I plug it in? Yes. I'm going to be very specific though, because it's fairly obvious in my picture that BE, which is X, right? They told me that very specifically in the problem, that BE is the shortest of the two chord pieces. So I'm actually going to just write X equals 2 because X is the shortest piece of the chord. So I wouldn't actually want to use the answer of X equals 10 because he would give me a longer chord than the other side. Okay, so if you want to put both answers, you can, but according to the diagram that I was given, the diagram is showing me that BE is the shorter chord. Now, like I said, if you want to put 2 and 10, I will take that because maybe our picture isn't drawn to scale, right? And so I would want to be careful and put both answers. I'll leave that up to you, but I'm just going by the picture and I'm just going to put 2. All right, almost there. Here we go. Let's see. EC is 4 and CD is 7. What is EA? All right, so I'm going to put that as X. All right, so this is still outside times whole, right? Outside times whole, not a tangent. The outside is the whole thing, right? And then outside times whole thing, right? So we're going to get x times x equals 4 times 11. And we're going to solve this. So we're going to get x squared equals 44, which is clearly not a perfect square. What is that going to be? 4 times 11. So we're going to end up with 2 root 11. Again, technically that would be plus or minus, but 2 root 11. But since we are talking about the length of a segment, we can only use the positive solution. All right, number 23. We've seen this problem lots, right? It says AE is tangent to both circles. All right, so, and the other thing we know about these two circles is that these are right angles. Again, I know they don't look tangent, but we're going to roll with that. If you zoom in, you're like, what? Anyway, so these are right angles because radiuses and tangents are always perpendicular to one another. And we also know that these two angles are congruent because they're vertical angles. And which obviously means that these two angles have to also be congruent, right? Which we can prove because these are parallel lines because of the right angles. Those are alternate interior angles, right? Plus we could use, you know, if two angles are congruent, then the third angles have to be. So many ways we could figure that out. Now, what we need to do is make sure that we recognize that these are clearly similar triangles, right? So I know this side corresponds to this side. Again, use your context clues, right? I've got the yellow box, the pink arc, yellow box, pink arc, right? Same thing. I know this side corresponds with this side, right? Pink arc, blue arcs, pink arc, blue arcs, right? I'm using my context clues. And then I know this side between the yellow box and the double blue arcs, they have to be corresponding sides. So I like to highlight those to make sure, because obviously I'm going to be setting up a proportion, right? That I'm going to get the correct sides matched up with one another. Because that's usually where people go wrong on these problems. All right, so here we go. So DE is 6. And EC is 8, and BC is 30. Okay. Now, so we're going to find all the other sides. Now, here's the kicker. I can't set up a proportion yet because not only do I not know this side, but I don't know this side either, right? And I have to make sure I'm using the corresponding sides. But the cool thing is these are all right triangles, yes? So when I have this right triangle over here, I'm like, sweet, I've got 2 of the 3 sides. So I can do a quick little Pythagorean theorem or realize that's a Pythagorean triple. And I know that that's a 6, 8, 10. Okay. So now I can solve for AB. I'll put a little X right there. And again, how you set up a proportion is purely up to you as long as you're matching up and corresponding stuff. So I'm going to say X is to 6, right? As 30 is to 10, because those, my little highlighted green segments, those are the corresponding sides, right? So I do a quick little cross product. 180 equals 10x, so x equals 18. So AB is 18 inches. All right, then I need to find AC. I'm going to put a little y right there. I'm going to set up another proportion. Or, of course, you can probably see what's going on with the scale, the ratios. But anyway, I'm just going to go ahead and do proportion. So I'm going to do y is to 8, because those are corresponding sides. And then I'm just going to go ahead and use the 30 to 10 again, which is going to give me 240 equals 10y. So y equals 24. And that is going to be the length of AC, 24 inches. Then the final question says, find the ratio of the areas of the big one to the small one. If you want to calculate the area, you can, but does everybody notice that you could also use a SPOV chart if you want to. I'll go ahead and just calculate the area. Right, so the area of triangle ABC would be 1/2 base times height. And the base and height are the 18 and 24 that I literally just found right there, right? Because base and height are the 2 legs that make the right angle, right? So if I calculate 1/2 times 18 times 24, I get 216. And then if I do that over here, right, I'm going to do 1/2 of 6 times 8, which gives me 24. So if I make a ratio of 2:16, basically what I'm doing, right, the ratio of the larger one compared to the ratio of the smaller one, right, then that reduces to 9:1. Now, did I have to do all that work? Absolutely not, right? You can think of your awesome, remember SPA charts, right? I automatically know from looking at these sides, right? Look at the sides, 30 to 10. So I know that my side ratio is 3:1, which means my perimeter ratio is 3:1, which means my area ratio is, you got it, 9:1. So I could have just done that thought process in my head and figured out that 9:1 right away. Again, how you get there makes no difference to me, right? As long as you can figure that out. All right, number 24. Here we go. I'm going to fly through these last few. Let's see. AG, okay, 100. CE, 30. And EF, 28. Okay, so there's lots of things that jump out at me. So the first thing that jumps out at me is says up here, it says given, and the first thing it says is circle P, which means circles are always named for their center. So P is the center of the circle, which means all those lines shooting out of it are radii, right? And so that's the first thing that I notice, which then clearly means like this is a radius, right? Which I'm going to go ahead and make a right angle box right there if everyone's cool with that. And I also know that this is a diameter. And if that's a diameter, then that means the whole top half of the circle has to be 180 degrees, as does the bottom of the circle, right? And so that's going to allow me to fill in all the rest of the arcs, right? I know arc FG has to be 80 degrees. I'm going to pick a different color, right? I know that's 80 degrees because semicircle, right? And on the top half, I know this is 122 degrees, again, half circle. All right, so from here, I should be able to start filling in quite a few angles. All right, so let's see. First thing that jumps out at me is that we have central angles. And central angles are always the same as their intercepted arc. So that means this is 100 and this is 80. So that's the first thing that I notice. Okay. Then I go look for inscribed angles. Okay, I'm going to start getting pretty messy here. So this inscribed angle, angle 3, he's intercepting this whole arc, which I can clearly see is 58 degrees, right? I can add the 30 plus the 28. And so angle 3 is going to be half of the 58, which means he's 29. But of course, I know this is a 90-degree angle, which means this is 61. Now, I know it didn't ask me to do that, but I'm going to go ahead and fill in all the angles I can. And of course, I knew that was 61 also because he's half the 122. So many different relationships, right? It's just kind of what your brain sees first. All right, let's see. The next angle that I'm going to go gravitate towards is going to be this angle 6 over here because he is an outside angle, which means he is half the difference of his two intercepted arcs, right? And I have the measure of his two intercepted arcs. So let's see down here, I'm gonna do a little measure of angle 6 is half the difference of 100 minus 30. Well, that's gonna give me half of 70. So the measure of angle 6 is 35. And I know I haven't written any of these in, but I will in a second. All right, the next thing I notice is I'm going to go pick up on angles 4 and 5. Now, clearly 4 and 5 are supplementary, so I just need to find one of them. And you can find either one of them right now, right? Because, let me go grab a highlighter. I'm going to do angle 5. I know he's an inside angle, right? He's an interior angle, not at the center. So I know he is half the sum of his two intercepted arcs, which are going to be the 28 and the 100. So I know the measure of angle 5 is half the 28 plus 100. All right, so half of 128 is 64 degrees. So he's 64. And 4 is his supplement, so 116. You also could have found that by averaging his two intercepted arcs, which would be the 122 and 80, right? Let's see. It looks like we have found everybody except angle 7. And let's see. Unfortunately, angle 7, he doesn't have a complete chord, so I can't use that. But I can use this lovely little triangle because I know that angle is 64 degrees because it is vertical to angle 5. And then I noticed that angle 7 is just the third angle of this little triangle going on. So I know I can just subtract that from 180, right? And that's going to give us 36 degrees left over. All right, I think we found everybody. All right, so here we go. I'm just going to go fill these in real quick. So angle 1 was 80. Angle 2 was 100. Angle 3 was 29. Angle 4 was 116. Angle 5 was 64. Angle 6 was 35. And 7 was 36. Now it asks me to find some angles on the circle. I think we've already found them though. So the first one says BAC. So BAC, and yep, I already found that one, even though I didn't need it. He was 61 degrees, right? Half of the 122. And then of course, measure of HAP, right? That's just a tangent with the radius. So that is a 90-degree angle. Okay. All right, see if I can get through the last page before my iPad dies. Here we go. Our last page is just circles, right? So this was our last day of notes. So writing the standard form equation of a circle, I'm just going to go ahead and write on the top the actual standard form formula, x minus h squared plus y minus k squared equals radius squared. So just don't forget that the hk is the center of the circle, okay? So it says, write the standard form equation of a circle with a center at negative 2, 3. Well, that's awesome because they gave you the HK. All right, so negative 2, 3 is going to be here. And then another point on the circle is 5, 2. 1, 2, 3, 4, 5, 2. Right, so we know our circle kind of looks like this action. That's not a very good drawing, but you get the point. Well, the cool thing is we already know the HK, so I'm just going to go ahead and fill that in. X minus negative 2, so this will be x plus 2 squared, plus y minus the k, which is 3, positive 3, so I'm going to put a negative in there, equals, now we just need our r squared value. So we need to go find the r squared. Now how you do this is totally up to you. Me personally, I'm just going to make a right triangle out of these movements really quick because there's my R, and I know this is 1. 1, 2, 3, 4. Yeah, it was 5. Okay, and this is 7. So I'm just going to do a quick little Pythagorean theorem where I do 1 squared plus 7 squared equals R squared. And you don't even have to solve for R because we want R squared, right? And so that's going to be 1 plus 49, which is 50. And we're used to solving for R, but guys, you don't have to, right? I want R squared. That's my formula, right? So I'm literally done. I'm just going to put 50 right here. Ta-da! Again, there's other ways you can do that. You can plug the x, y, hk into the formula and then solve for the r squared. It's all the same, right? So we talked about that in class. There's multiple ways to do these problems. So pick a method that resonates with you. All right, number 26. A clock. Oh, clock math. You know how much I love it. So clock math. It's basically saying at 2:30, what is the angle formed? Well, 30 is a nice, easy one, right? We did harder ones in class, right? But 2:30, I'm just going to write. So that means my hour hand is actually going to be halfway between the 2 and the 3. But my minute hand will be here. So we're looking for the measure of this angle because that would be the measure of this arc, right? So essentially keeping in mind that every degree is 6, or every minute, sorry, is 6 degrees. So every 5-minute interval is 30 degrees, right? This is what we talked about in class. So every 5-minute interval is 30 degrees. Well, if I'm at 230, shoot, I'm going to go ahead and write the 4s and the 5s. There we go. So we've got a 30-degree interval, 30 degrees, 30 degrees. But of course, this is not going to be a full, this interval right here, he's going to be smack dab in the middle. So he's only going to give us 15 degrees, right? So 30, 30, 30. And if you're not sure if that's 15 degrees, you're more than welcome to set up the proportion, right? And you can figure that out pretty easily. All right, which means our answer is 105 degrees. You might want to add a harder example like the one that we did in our notes or some of our homework questions. You might want to add that to your note card if you are going to forget how to calculate those. Okay. All right, last couple. Given circle C, which means C is the center, CB is 5, AB is 12, AC is 13. Is AB tangent to the circle? Well, it is, right? Because, and we can prove that, which you would need to show some sort of math, right? Because we know that we're basically doing the corollary to the Pythagorean theorem, or the converse, that says 5 squared plus 12 squared. Is that equal to, question mark, 13 squared? Well, of course, we know it's equal because that's Pythagorean triple, right? But the fact that this does work in the Pythagorean theorem, or you could just, if you don't want to write the Pythagorean theorem stuff out, you could just write, yes, Pythagorean triple. I'd be totally cool with that, right? Which does prove that this is a right angle between the radius and the tangent, right? Which is always true, right? So these numbers do work. All right, last question says, write the equation in standard form and then give the center, the radius, and the x-intercepts. Okay. Here we go. So remember, this is general form of a circle. We want standard form, which means we need some squared binomials. And if we have squared binomials, then we need to start creating some perfect square trinomials to get those squared binomials. So remember, I like to set up, I like to get all my x squareds together and then put a little box because I know I'm going to have to complete the square. Then I do all my y's together. Now, something I do notice is that there's a 4 over here. I don't want him over here, right? I'm going to subtract the 4 and get him to the other side because all my constants need to be over there. So I'm going to go ahead and put 11. All right, and now we just need to complete the square. So remember the number that completes the square, you go to look at your b term. Yes, I know. Thank you, iPad. I'm going to take half the b, which would give me -3, and then square it, and that gives me 9. And then I'm going to take half of 10, which is 5, and square it, which gives me 25. Now, what I don't want to forget, and I actually forgot to draw the box, you have to remember that you just can't randomly add a 9 and a 25 to the left side of an equation unless you balance it on the other side. So I just added 34 to a problem that was not there originally. So I need to make sure that I add that same 34 to the right side of my equation. All right, and now I just get to factor. I know x squared minus 6x plus 9 is going to factor down into x minus 3 times x minus 3, or x minus 3 squared. There's our squared binomial. Plus, and if I factor the y trinomial, I'm going to get y plus 5 squared. And then I add the 11 and 34, and I'm going to get 45. And that is our standard form equation. It takes 2 steps. Nice and easy. It does want us to identify the center, which is, of course, the HK, which would be 3, -5. And then the radius is going to be the square root of the 45, right? So that's going to be 3 root 5. Just leave it as a radical. And then last but not least, it asks us to find the x-intercepts, right? So remember, the x-intercepts are what are the x values when y is 0. So I'm going to take my standard form equation, and I'm going to plug a 0 in for y, and then I'm going to solve for x. That's what we're looking for. All right, so that's going to give me, I'm going to leave my x minus 3 squared binomial because we like squared binomials. I'm going to get 5 squared is 25. All right, then I'm going to subtract that 25 to the other side, which is going to give me 20. Then I'm going to square root both sides Now, obviously 20 is not a perfect square, and that's okay, right? But squares and square roots cancel, which allow me to drop the parentheses. So I'm going to get x minus 3 equals plus or minus, don't forget, 2 root 5. And then I'm going to add the 3, which of course goes in the front. We've talked about that numerous times. And so I'm going to get 3 plus or minus 2 root 5. And those are my x-intercepts. If you just want to leave it like that, you can. If you want to be super fancy, you can split your answer up and write those as 2 separate coordinates, 3 plus 2 root 5, comma 0, like that's one of our x-intercepts. And then our other x-intercept would be 3 minus 2 root 5, comma 0. Right? I'm fine either way. However you want to write your answer is completely up to you. I'll take it either way. Whew. All right, you guys. Whew, just the nick of time before my iPad died. All right. I hope all that makes sense. If there's anything you have a question about, feel free to come in before and after school, and I'd be more than happy to help you out before we take our test. I'm going to delete that. All right. I'm just going to scroll back up top. All right. Happy studying, y'all.